Hello all you super geniuses out there. Welcome to another video lecture from Super Genius 99. Today we're going to be talking about tests for symmetry. So we got a little board up here. So symmetry, here's the symmetry and then here's the test. Okay, so symmetry, WRT means with respect to. Okay, so when we're testing for symmetry with respect to the x-axis, x is replaced with, so an equivalent equation results when x is replaced with the negative x. And we're going to work examples here. So basically it's like you replace x with the negative x. If you get the same equation, that means it's symmetry to the y-axis. So x-axis, symmetry with respect to the x-axis is true if, when you replace y with the negative y, get the same equation. And something is symmetrical to the origin if you replace both your x with the negative x, your y with the negative y, and you get the same equation. So let's see what that looks like. So we're going to first take this equation here, y equals 2x minus 4, and we're going to test to see if it's symmetrical to the y-axis. So if we want to test something symmetrical to the y-axis, replace the x with the negative x and see if you get the same equation. So let's do that. So I'm going to have y is equal to 2. I'm going to replace the x with the negative x. See if I get the same equation. Let's see. Negative x. Okay. So what happens if you multiply 2 by negative x? Right? 2 times negative x is negative 2x. So does this equal your same equation? No. So in this case, this one is not symmetrical to the y-axis. Let's see if it's symmetrical to the x-axis. Okay, so if it's symmetrical to the x-axis, I should place the y with the negative y and get the same equation. Let's see. Okay. So I'm going to replace y with the negative y, so I'll just go ahead and put it there. Negative y is equal to 2x minus 4. And then multiply everything by negative 1, so you have y is equal to negative 2x plus 4. Does that equal your original equation? No. So it's not it's not symmetrical with respect to the x-axis or the y-axis. And let's see if it's respect to the origin. Okay. So you replace your x and y with the negative x and a negative y. So we'll have negative y, get that hunk of junk off of there. Okay. Negative y equal to 2 times negative x okay, minus 4. Let's simplify that. 2 times negative x, so we have negative y is equal to negative 2x minus 4. Okay. Then multiply everything by negative 1 because we always like our equations to be y equal to 2x plus 4. Is that the same? No. So it's not respect to the origin either. Oh, when I was in grade school, many moons ago, we were taught that if it's not respect to both the x and the y, then it won't be respect to the origin. So there's your shortcut. But if your teacher asks you to work it out, you better make sure you work it out. Okay. Let's do another one. Okay. Got a fresh problem on the board. Y is equal to negative x. Let's see if that is symmetrical to the y-axis by replacing the x with a negative x. So that is y is equal to 1/2 negative x. And when you work that out, you get y is equal to negative 1/2 x. Okay? Is that the same as our original problem? No, so it's not symmetrical to the y-axis. So no on that one. Is it symmetrical to the x-axis? Well, replace the y with the negative y. Let's see what happens. So negative y equal to 1/2 x. So y is equal to negative 1/2 x. Does that equal your original equation? No, so it's not respect to the x origin either. Let's see what happens to replace x and y with the negative x and negative y. So y is equal to negative y is equal to negative 1/2 x. Okay. If you multiply everything by negative 1, you get y is equal to 1/2 x. Okay, so it looks like it is respect to the origin, but not the x and not the y. Okay. All right. So there's that one. Let's do another one. Okay, here's another one. Absolute value of y is equal to x. Okay. So let's test for y-axis. So replace x with the negative x. So absolute value of y is equal to negative x. Simplified, you get the same thing. Nope. That is its simple form. So y-axis, no. Let's try the x-axis. Replace the y with the negative y. Simplify that, what do you get? Okay. And is that the same as the original? Yes, because when you have absolute value, it's always, that number, so that is true. How about the origin? Simplify that, what do you get? And is that the same as the original? Nope. So you got the x-axis, and that's it. Okay, let's look at one more. Okay, so we got the absolute value of y is equal to the absolute value of x. So is this is this the same? Does this have symmetry with respect to the y-axis? Well, let's see. So you replace the negative x, and that'll give you this. Well, when you simplify it, it'll give you this. Yeah, same thing as that. So that, in essence, will give you that. So it is symmetrical to the y-axis because, your absolute value always comes out to be a positive number. Okay. All right, so how about symmetry to the x-axis? Well, place y at the negative y. That just simplifies that. And so that's true. And I think I said the shortcut backwards, but I'll say it right this time. The shortcut is if it's respect to the x and the y, it's automatically respect to the origin, not the other way around. So if x is true, the x is true and the y is true, symmetry respect to the origin, symmetry respect to the x and the y, then symmetry to the origin is induced. But it doesn't mean if you don't have an x or you don't have a y, then you don't have an origin. No, if you have an x and you have a y, then the origin symmetry exists as well. But let's go ahead and test it. So does the absolute value of negative y equal the absolute value of negative x? Yes, because the absolute value of negative y, the absolute value of negative x does reduce to that. Okay, so you got the x-axis, you got the y-axis, and you got the origin, all three in one. Okay, so this has been a video lecture from Super Genius 99 over tests for symmetry. Thank you for watching. Have a wonderful day.